full disclosure, I happened into a couple of Arduino Unos a couple months ago, and I've been sort of looking into using them for something, thinking of how I could use them, just kind of wanting to learn about them. And in doing so, I came across people talking about microprocessors, microcontrollers. I thought, well, before I start this, I'll look into it, right? Because I have an Arduino, and that's a microcontroller. So that's what I thought, and I found out very quickly that I was wrong, and now I'm going to share kind of that information with everybody here. So first, we have microprocessors, microcontrollers. What are they? What are they used for? How can you tell them apart? How can you start to use one? And then jumping down into some Arduino code later. So a microcontroller is a computer on a single IC, contains RAM, ROM, and some other peripherals, maybe a timer, and they are most often pre-programmed, right? So an IC is an integrated circuit. This is going to be a single microchip. RAM is random access memory, and ROM is read-only memory. So since these are mostly pre-programmed, a lot of them just program ROM and are used for a few things, right? So you can use them for embedded applications. So that would be an application maybe in a traffic meter, your microwave, your thumb drive, an older car radio, not one of the kind of smart car touch radios. These kind of sorts of small computer applications. Cool. So that's kind of the basis for what a microcontroller is. Now, microprocessor is a little bit different. This is an integrated circuit that incorporates all the functions of a CPU on a single chip, right? Cannot store programs internally, and they load their software or operating system when they power on, right? So what does that really mean, right? So microprocessor is used in pretty much every computer that we use now. They are really, really important in how we use computers, especially laptops, anything smaller. So why microprocessors? Why not a processor? Well, these microprocessors were previously done on larger circuit boards or circuits, and making them smaller and putting them on one chip helped a lot with a big shift in both speed and power usage. And these microprocessors, they just really perform basic arithmetic. They get a bit of input from your basic input and output service, usually shortened to BIOS. And then once they're turned on, different programs will kind of drive the CPU in your computer. Cool. So the differences. Microcontrollers are much cheaper and slower. They are not meant to do the same thing, and that's why they're used for kind of smaller embedded applications and single purpose type programs. Microcontrollers run code in place, where microprocessors run code on peripheral. So since there's no memory in a microprocessor, it needs to run its code someplace else. So like the RAM in your computer, or from the hard drive in your computer, and it in turn controls those things. They're also a lot faster and take a bit more power. Microprocessors, like I said, find application tasks where the relationship between input and output is not necessarily defined. So basically, software engineering, building software and running code is something that's a little bit better served by a microprocessor than a microcontroller. Cool. So I'm going to jump straight to in use here, right? So contrary to my misconception earlier, an Arduino is not actually a microcontroller. So I was under that impression. So What an Arduino is a system or board used for programming microcontrollers. On this chip, this is the only part that's a microcontroller, and it's used to control the rest of the different things on this. So there's these pins. I think there's a light over here. There's a power source, and there are different voltage outputs that let you perform simple machine actions. So what to do now? now that we have this information, you can write or find some code online. You can load it onto a microcontroller. And specifically for Arduino, I'm sure other ones as well, there are libraries for most major languages to support writing to these things. Specifically on Ruby, the serial port gem and Dino gems will allow you to manage the hardware and have direct control over the ports. And there's also a library called R2, which I found to be a great resource for any sort of machine programming. So once I got this information, I thought I would write some amount of a simple hello world for an Arduino here. So here's specifically the code. You set up a connection to a specific board with the serial port. I'm using Dino in this example. And I set my LED light to a variable, which is the specific pin on that board. And using the LED component for that, or using the LED object that's embedded in the Dino library. Now I just send it a method, right? So you can send LED, this symbol on. I can sleep and send it off, right? So I have short and long methods here for 0.25 and 0.75. Then I have a method called hello, which will just in Morse code blink hello on a Arduino as it runs.